We can evaluate definite integrals that involve exponentials. Now that we know how to find the integral of an exponential, e to the 2x is going to be our exponential, so we want e to the u, so u will equal 2x. Du is going to equal 2 dx. So we need a 2 on the inside, therefore we'll have to put a 1/2 on the outside. So we have 1/2 times the definite integral of 0 to 3 of e to the 2x times 2 dx, which is in the form of e to the u du. And the integral of e to the u du is e to the u plus c, but because this is a definite integral, we are going to evaluate from 0 to 3 and drop that limit of that constant of integration. So we have 1/2 times e to the 2x evaluated from 0 to 3. So we'll have 1/2 times the quantity e to the 6th minus e to the 0. 2 times 3 is 6, 2 times 0 is 0, e to the 6th minus e to the 0. Be very careful here that the numbers aren't playing tricks on your brain. You've got 1/2 times the quantity e to the 6th minus 1. So this is an exact answer. Because we can't do anything else with that. Let me bubble it. A bubble will look a little bit nicer. And then an approximate answer, if you were to put this into your calculator, let's make sure that you know how to put that into your calculator. Check and make sure that you get 201.21, and that's an approximate answer. So approximately 201.21. Okay, we'll do a couple more examples because, of course, we've got the integral of 1 over x dx evaluated from 1 to 2. Well, that's wonderful because we don't have to use u substitution there. The integral of 1 over x, or the antiderivative of 1 over x, is the natural log of x. So we're going to have the natural log of x evaluated from 1 to 2. Now, I didn't use absolute values because my limits of integration, 1 and 2, are both positive. So I'll have the natural log of 2 minus the natural log of 1. And the natural log of 1 is 0. So the natural log of 2 minus 0 is just the natural log of 2. And here we have the definite integral from 1 to 4 of -3 times the square root of x dx. Well, we're going to evaluate this by taking the -3 to the outside. We've got x to the 1/2 dx. When we take the antiderivative of x to the 1/2, we're going to get x to the 3/2 times 2/3. We have the -3 on the outside, and we're going to evaluate this from 4 to 1. So we will have -3 times, we put a 4 in, the square root of 4. Let me show my work. 4 to the 3/2 divided by 3 minus 2 times 1 to the 3/2 divided by 3. This 4 to the 3/2, the square root of 4 is 2, 2 cubed is 8. So we're going to have 2 times 8 is 16. So -3 times 16 thirds minus 2/3 is going to equal -3 times 14 thirds, which is -14. This negative, when negative, the region, because remember this is area, the region sits, that shaded region that we were shading in our color, in our graphs, that shaded region sits, ooh, that was close, sits below, hopefully that brought a smile to your face, the x-axis. If you don't know what I'm talking about, just keep watching, instead of above. And I'm going to repeat that because I'm talking about two things at one time there. When the negative is a result from your definite integral, that means that the region, that area that we were finding, sits below the x-axis instead of above the x-axis. So that's an interesting fact to know. Okay, here's a few for you to try. I'm going to come back with just answers so that you can check to make sure that you've got these two tries. And the answer to the first is 1/4 times the quantity e to the 4th minus 1. If you did put that in your calculator, you get approximately 13.40. And the second one is the natural log of 2/5, and I'll show you just part of the work. Natural log of 5 minus the natural log of 2. That would be -1 times the natural log of 5/2. When you bring that -1 to, let me show you, -1 times the natural log of 5/2. When you bring this -1 to make it an exponent, you get the natural log of 2/5. So this is an exact answer. And if you were to put that in your calculator, you would get approximately -0.92.